Today we're talking about linear inequalities. Before we can actually start solving them or graphing them or anything, we do need to understand a few of the symbols and terminology. This is a greater than or equal, and we'll be using brackets. And less than or equal, we'll use brackets also. And greater than, we just use parentheses. Less than, we use parentheses. The infinity sign, which means that it goes to infinity, is always a parentheses, and negative infinity would also be a parentheses. So this right here is what we call set builder notation, and we read this is for all x. X is going to be greater than or equal to 4. That's how we read this, and I'll show you how to do the set builder notation on some problems in a little bit. So let's go on to graphing some problems, and let me erase. We can start with this x is greater than or equal to 4. So once again, this is for all x. X is greater than or equal to 4. So we'll have a number line here, and you want to start with at least 4 and then have some numbers around it. So whatever numbers we have in our set builder notation, you want to have on your graph, and then a few numbers on either side. Since this is greater than or equal, we're going to be using either a closed circle or those brackets. I usually start with a closed circle for these just because I don't know which way they're supposed to go yet. So I'm going to say that we always put a closed circle for greater than or equal or less than or equal, and it's going to be at 4. So we know we have something to do around 4. Now there are several different ways that we can, or two different ways we can look at this. If x is on the left side of our inequality, then we can go by the way it's graphed and by the way it's pointing and just graph it. What I mean is x is on the left, this is pointing to the right, so we just go to the right. I prefer though, even if you do this way, you make sure you read it and check it. So what I mean is it true that 5 is greater than or equal to 4? Because I pick a 5, I put it in for x, x is larger than 4, x is larger than 4. Yes, we graphed the right way, okay? So we have the set builder notation was here, and we graphed it, and let's do another problem. Okay, so here we have for all x, -7 is greater than or equal to x. So we're going to have a graph, and we're going to have at least a -7, and we're going to have some numbers on either side. Remember, as you go to the right, the numbers get bigger. The more you go to the left, the numbers get smaller. So we have to have at least 3 or 4 numbers there. So once again, this has a equal sign, so I'm going to put a closed dot right at the -7, and then I'm going to read it. Now remember, I said that if the x is on the left side, we can graph the same direction that's pointing. Is x on the left side here? No, I have a number on the left side. So this could be rewritten and go x is less than or equal to 7, because see the x, the smaller point, and then -7. So then now x is on the left side, and we could graph it in that direction. Always double check. Do not just go with that and say that's it. Put in a -8. -7, is it greater than or equal to -8? Is that a true statement? Yes, -7 is larger than -8. If I owed somebody only $7, that's owing them less than if I owed them $8. So that means that -7 is more than -8. So we got that, and that's checked out. Okay. We're going to move on in the next section to how to solve these inequalities if we're given one. So I'll see you in a little bit.